Good morning, everyone. Is my voice audible to you? Please confirm through the chat box. Anyone, please? Both audio and video. Are you able to see my screen? Please confirm by yes. Thank you. Okay. We'll start our class just within 1 or 2 minutes. Let's all the participants come. Okay, fine. In the last class, we have started our 5th unit, that is pattern matching and price. And we have seen about the pattern matching. Means when we are given with a text and some pattern, we have scanned that pattern in the text and we have found where that text is going to be located. And we have given the result as this pattern has been found at so and so location. And we have seen 3 types of algorithms, that is brute force, Boer-Moore and KMP algorithm, which are going to be perform this pattern matching. So we have seen about the brute force in the last class. Now the next algorithm we are seeing for the pattern matching is today's Boer-Moore algorithm. So this is also same for pattern matching, that is finding a pattern P in the text T. Same process, but with some advanced features. So this Boer-Moore algorithm also search for the pattern P in the T, but by performing some explicit character comparison at different alignments. Instead, in the brute force, we have searched for all the alignments in the text, and for the each character, we have searched for the pattern in the T. So we have searched all of the character by character in the brute force. But now in Boyer-Moore algorithm, we are not going to follow the same process. We are going to skip some shiftings. How? We'll see further. So in the last, we have seen in the brute force that when we are given this an example, when we are finding a simple pattern in the text, that is, this is a simple example, this is my whole text. In that, what I am finding a simple pattern in this text. So I have started from the very first index 0 and have tried to find this simple in this text. That means I am trying to matching this simple with this given string. So as I have checking by character. So first character doesn't match. So I have shifted to one position. So I have shifted till what time? Till my pattern has got match in the text. Till that time I have did shifting. So but in this Boyer-Moore algorithm, shifting process is not same as of brute force. It's going to skip those shifting by using two important features, that is a bad character heuristic, that is a bad character rule, and a good suffix heuristic, good suffix rule. And in the last brute force, we have seen that we are matching the pattern starting from the position 0 till M. That means we are starting from the left, right? But in this Boyer-Moore algorithm, what we'll do, we'll try to scan the pattern from the right to left. So we'll start from right side of the pattern. So Boyer-Moore algorithm is a combination of two approaches, that is a bad character heuristic and a good suffix heuristic. Each of them used is independently. So by using any one of this rule, Boyer-Moore algorithm is going to process the pattern matching problem. Either bad character rule it will use or good suffix rule. Any one it can use and perform the pattern matching. So it is not like we are supposed to use both at a time. It can be used only one. So let's see what is a bad character heuristic, that is bad character rule. So in the last brute force, when we are getting a mismatch, what we were doing, again we were starting from the 0th index and we were trying to match our characters, right? So here it will be something different. So the mismatch character, so you can see on your screen, I have taken an example in which the upper string is my text and the small string is my pattern. So I am going to match this pattern with respect to my text. So the character of the text which does not match, if so first what we are doing, first we are keeping these pattern at the 0th index. Now we are starting matching. How? Starting from the right side, because it follows right to left pattern. So first we are going to check for the m-1 index value, because m is the length of the pattern, right? So m-1. So these are, so totally how many characters are there in my pattern? There are 6. So length is 6. So m-1. So at the 5th index I need to start. So I'm starting from the right side. So I'm trying to match. So first character is being matched. Then the next character has been matched. Now there is mismatch occurs, right? So the when we are getting a mismatch, so at what character we are getting mismatch? At the character A of the text, we are getting a mismatch. So for that A character, we are going to call it as a bad character. So where our mismatch occurs at that character is going to be called as a bad character. So upon the mismatch is going to perform two things. So it's going to perform shifting. First, it will perform shifting. At what time it will perform shift? Till what time? Until what we are supposed to perform shifting? Until the mismatch becomes a match, first condition. And the second condition, pattern P moves totally past the mismatch character. So first what we are doing, we are finding a bad character, and after finding a character, we are checking for these two conditions now. What is that first one? What we are doing upon the mismatch, then we are shifting this pattern until mismatch becomes a match, or pattern P totally moves the mismatch character. Totally it passed the mismatch character. We'll see with this example. Here I have taken an example. So we have already seen a match has been occurred and we have found a bad character. So first case, we are seeing a first mismatch becomes a match. How mismatch becomes a match means now I got a bad character. So what I'll do, I'll check whether this A is present in my pattern or not. Again, it's going to be occurred or not. So I can see, yes, it is going to occur at the position 1. So what I have to do, I have to align, or I have to shift these patterns in such a way that these A and A is going to become a match. Now it has been mismatched now. So in the next step, I need to be shift this pattern in such a way that at this position A, I have to get a match. So what I am doing, so here two positions, I am shifting this pattern. So in the next step, I have shifted this pattern. So the my mismatch, which was in the previous step, it is now match, right? So as we have found a bad character, what we are doing, we are shifting until a mismatch becomes a match. Now match has big. Now this is a match. Previously it was a mismatch. Now it is a match. So again, what we'll do? Again, we'll start from the right side because it follows their terminology, right? From right to left. So again, we'll check for this. Now again, a mismatch has been occurred. So again, we'll look. Now this C is my bad character. So again, I have to look for C in my pattern, whether this C is existing or not. No, it's not existing. So this first case has been completed. Again, we are not able to find the C character in my pattern. So what I have to do, I have to move for the next step. What is the next step? Total pattern P have to move past the mismatch character. If we got a condition like there is no character is matching in your pattern P, then what we are doing, what we are doing is like in this example, in second case, that is pattern move past the mismatch character. So what we are supposed to do, this is a mismatch again I am, what I am doing, I am looking for a C in my pattern. So I'm unable to find a C in my pattern. So what I have to do, I have to move total pattern past the mismatch character. So mismatch has occurred at the what position mark? It has occurred at the 7th position. So I have to match whole this pattern past the 7th position. So I'm totally placing this, shifting this pattern to from 8th position. So here, as I have shifted, luckily all the characters of my pattern has been matched with the characters of the text. So we have find out the pattern in the text, right? So in just 3 steps, we got our pattern in the, we have scanned the pattern in our text. So what we have been in the first step, we have found a bad character and we have made a mismatch as a match. Again, we have found a mismatch. Again, we have checked whether it is existing or not. If not, what we have done, we have, with the help of the case 2, we have shifted whole pattern past the mismatch character. In the second step only, we have found our pattern in the text. So just in the simple 3 steps, we got our pattern match with the given string. Whereas if we use the brute force for this same example, we would have done various shiftings. Again, we need to start from the 0th index. So it would have taken some 14 to 15 steps to do the same. So this is the main advantage of the Boer-Moore algorithm. So by using a bad character rule, it avoids shiftings. Hope you got it. So I have given this example, and the explanation of this example, I have given the same thing here. Huh? So in the place at the position 7, we got the mismatch and the character C does not exist in the pattern. So we need to shift all the pattern positions, and eventually we have got perfect match here, which is showing in the blue color. So at every before seven, there was no possibility of matching. So what we have did, totally pattern, we have shifted past the mismatch character. So now we got our pattern matched with our string in the text, given text. So this is a main advantage of Boer-Moore algorithm. By using a bad character rule, it's going to perform this pattern matching by avoiding shifts. So we'll see an algorithm for this. And one thing, in this, what this Boer-Moore algorithm is going to do, it's going to pre-process the pattern. It's going to study the pattern first, and it going to maintain a last function for the pattern. What is that last function? Whatever the values here, whatever the characters we are getting in the text, it's maintaining its last occurrence in a table, so that it can utilize that value and it can perform in the functions, and it avoids the shifting. So for that, it maintains one table called as last function table. So here it maintains, for every character, it maintains one value as last occurrence value. What is that value? How we'll find? We'll see here. See, last of character value. How we are going to find? We are going to find as index of the last if the character C in the pattern occurs of the character C in the pattern P. So that means at what index that character has been exist last. So in here, in my pattern, given pattern, A is occurring 3 times at the 0th index, at the index 2, at the index 4. So at the last, what value A has been exist in my pattern? It was 4. So the last of A, I am going to take the value as 4. And in the pattern, you can see B has exist in 2 times. That is first at 1 position, again at 5th position. So the last value of the B, I am going to take it as 5. C has only exist 1 time, that too at the 3 position. So I am taking the value of the last of C as 3. D doesn't exist anywhere. So if it doesn't exist anywhere, we are supposed to take it as -1. Otherwise, otherwise, we are supposed to take the value of the last function, last value of that character as -1. So by using this last function is going to implement an algorithm. So we'll see an algorithm for this. This is an algorithm for Boer-Moore. What we are going to do, we are going to give input, that is one pattern, one text. So the pattern is a string which we are supposed to match in the given text T. So we are providing 2 inputs. And first step, what we are doing, we are finding a last function table. That means we are executing the last function. We are preparing a last table for the pattern. And what we are doing, we are finding a m and n values. What is m? It is a length of the pattern. So length of the pattern is going to store in the variable m, and length of the text is going to store in the variable n. And we need two variables I and j so that we can shift our pattern and check with respect to the text. So I is for explicit checking and j is for within the pattern. Last in the last class also we have checked in the brute force same, right, with the help of I and j. In that case, in the brute force, what we have did previously, we have initialized I and j with zeros. That means we have started our search from the left side. But now here what I am initializing here, I with m minus 1 and also j with m minus 1. So we are performing a search from the right side of the pattern. So both I and j value I am assigning with m minus 1. So we are beginning from the right to left here. So again in the algorithm we are using a do while function. So first perform this all the function, then at the last check for the condition. So in the do section we are doing this, and in the last we are checking for a while condition here. So what we are doing, we are checking for the both the arrays, that is a pattern array and the text array, and we are looking each character whether they are matching or not. So if they are matching, what we are doing in the second condition, if condition, we are checking for the j also. Is that j value is equal to 0? If it is, whatever the value, whichever the character has been matched and which j value has been 0, then at what index these both characters are equal, we are returning that I value so that we can print this pattern has been found at that position I, that position 0 or position 4 we are supposed to print now. So we are returning that value. Or else if it is not match, if it is match is found, and else in if j is not equal to 0, so what we are doing, we are decrementing the value. In the brute force we have incremented, right? So here we are decrementing. So I with minus 1, I minus 1, and with j minus 1, right? If these both the character doesn't match, what we are supposed to do, we are supposed to take a help of the last function, and we are supposed to change, we are supposed to increase or decrease the value of I with the help of that last function. So here I am using that last function for changing my I value. Again, j value is going to be decreased, and it checks for the condition whether my I value is less than my total text length. If it is exceeding, that means pattern is going to extend the, going to exceed the level of the text. So it's going to more right side. So till whatever the length of the text has been given, at that position only we are going to supposed to check, right? So if it is going to extend, then we are so going to return it as no match. That means none of the characters of the pattern has been matched. So we are going to return as a no match if it is going to exceed. So now let us look this by one example now. So here I have taken one example at the right side. You can see on your screen, I have taken a text of string, that is some digits are there, and one pattern I have taken. This example I have given as an assignment for you in the last class. I hope you have done this for brute force. Now let us will check this condition with Boyer mode. So in the text, I am trying to find this. So by looking these four characters, you can easily find that at the position 0, 1, 2, 3, at the position 2, that is index 2, this pattern is going to match in this text. So by just by looking, we can see. So by using Boyer mode, how we are supposed to do, let us find it out. So first of all, what we need to do, we need to execute a last function. That means we are supposed to find a last occurrence table. So here, how many characters are there in my pattern? Only two characters are there. That is a 0 and 1 is there. So what is the last occurrence of 0? So you can see the second table, second. So at the 0, first it's getting at the 0 index, then at the 1 index, and the index 2. So the last occurrence of the 0 in my pattern is 2. So I am taking the value, last of 0 value is 2. And the last value of 1, it's occurring last in my pattern at the position 3. So I am taking the value it as 3. So we are done with the last function. Then next thing what we are supposed to do, we are supposed to get the values of m and n. So here m, what is the m? It is the length of the pattern. So how many length characters are there? 4 characters. So m is now 4. N is the length of the text, input text. So how many characters are there? 6. So I have initialized as a 6. Next, I and j value has to be initialized. So as we are performing from right to left, so it will be m minus 1. So 4 minus 1, 3. So 4 minus 1, again I and j has been initialized to 3. Now we are supposed to perform a do before checking a while condition. So what we are doing, we are checking is p of j is equal to t of I. So p of 3 equal to t of 3. So what is p of 3? Pattern of 3, 1. And t of 3, what it is? 0. So 1 equal to 0? No, it is not. So it's going to exit. So total this loop is going to exit and comes to the else part. In the else part, what we are having? We are supposed to get the I value by using a last function. So here I am solving the I value here. So I plus m minus minimum of j comma 1 plus last function of t of I. So here I value, it was previously 3. So m, that is the total length, 4 minus minimum of j. J, what was the j value? It was 3. Again 1 plus last of t of I. T of I means I, what was I? T of 3. So t of 3, 0. So what was the zero's last value? It was 2. It was 2. So 1 plus 2, 3. So minimum of 3 comma 3, it's 3. So how much the value means? 3 plus 4, it's 7. And minimum of 3 comma 3, it's 3. So 7 minus 3, 4. So now I value is 4 and j value is 3. So again, it needs to check this condition whether I is less than n minus 1. So what is I here now? It is 4, right? Now it is 4. So we need to check it is less than n minus 1. What was my n? It was 6. So 6 minus 1, 5. So 4 is less than 5. Yes, it is. So it doesn't look this step. It goes back to the do loop. So again in the do loop, what we are supposed to do? We are supposed to check if p of j is equal to t of I or not. So what is my p of I? What is I? What is, sorry, p of j equal to t of I? So what is my p of j? What is j here? 3. So p of 3 is equal to t of I. What is my I now? It is 4 now, right? So it is 4. So what is p of 3 here? So p of 3, we are having 1. And what is t of 4? It is here. You can check here. You can check here. It is 0. So whether they are equal? No, they are not equal. So 1 is not equal to 0. Again, if it is not equal to 0, what we are supposed to do? We are again supposed to find the value of I by using a last function table. How? This one. Again, we need to evaluate this, right? because it has been not matched. So again, it has been not matched. So again, we are going to click this else condition. So now, as 1 is not equal to 0, again I am finding the value of I, that is I. What is I? 4. Now 4 plus M. What was the M? Length of the pattern, that is 4, minus minimum of J. What was my J? Here it was 3. And the last function of 1 plus last function of I, that is last of 4. What was the 4? 0 is there. So last value of 0, what was it? It was 2. So again, my I value is going to be, I value is going to be 4 plus 4, that is 8, minus minimum of 3 comma 1 plus 2, that is 3. So minimum of 3 is 3 comma 3 is 3 only. So my I value is going to be 5 now, and J value is how much? It is 3 only. It was 3 only. So again, by using this I and J, after getting an I and J, what we are doing, we are checking for these conditions. I is less than n minus 1. So now I is 5. 5 is less than or equal to n. So 5 is less than or equal to 5. It is not less than, but it is equal. So condition is going to satisfy. Again, it's going to check for the do loop. In the do loop, what is going to check again? P of j equals to T of I. It's going to check. So now P of j, what is j? What was j? It's 3, right? So P of 3 equals to T of I. What was I now? It is 5. So now it's again going to check. So at the P of 3, what we are having? It's 1. Now T of 5, what we are having? It is also 1. So now match has been occurred. So next step, so as we are going to match, what we are supposed to do? Check for the J. Is it 0? No, it is not 0. Next, else part is going to perform. What is the else part? We are supposed to decrement the I and J. So I has to be reduced by 1 and J also has to reduce by 1. So as my I was previously, it was 5, it's going to change to the 4 and J is going to change to the 2 because previously it was 3, right? So again, after doing this, it's going to skip this. Again, checking for the condition I less than n minus 1, 4. Yeah, 4 is less than 6. So again, it's going to perform a do function. So in that, what it's going to check? Now it's checking for P of j equal to P T of I. So P of j. So P of j means P of 2 equal to T of I. So what is T of I? I is 4. So T of 4 is going to check. So what is P of 2? That means it's here going to be, means my pattern has come to this position now. So it's checking for the So P of 2. What is P of 2? So P of 2 is 0. And what is T of 4? It is also 0. It is match again. So after matching, again what we are supposed to do is we are supposed to check for the J condition, whether J is equal to 0 or not. So what was my J here? It is 3. So it is not, sorry, it was 2. So it is not 0. So again it's going to else part, and again I and J value is going to decremented. Now I will be 3 and J will be 1. So again, we are going to check here while condition I is less than n minus 1. So what is I 3? 3 is less than or equal to, yes, it is less than 6. So we are going to perform again do loop. So again, we are performing for do loop. What we are checking here, P of now, it is P of 2 now. Sorry, P of 1 now. Previously it was 2, so it is now 1. So, and T of 3 we are checking. So what is P of 1? It is 0. So you can check here, P of 1 is 0. So from the right to left, we are moving map. You can check. I have checked for 3 and they're checking for 2, then checking for 1 now. So 0 equal to 0. Yes, it is a match. Again, what we will do, we'll check for the J condition. So as it is not equal to 0, again, we are going to decrement the I and J. So what was previously I was 4. So now it's going to change to 2. Sorry, it was 3. Now it's going to change to 2. J, it was 1. Now it's going to 0, right? Now it's going to be 0. Against this else pass is going to escape and checking for the I, it is less than given string or not. Yes, 2 is less than 5. So again, we are going to perform a do loop. So we are checking P of J. So P of 0 equal to T of I. So T of 2. So we are checking here. What is P of 0? 0. And T of 2, 0. Again, we are getting a match here. So from starting from right to left, total string has been matched here, right? Right. So when I have shifted this, so totally my pattern is going to match with substring of the text, right? So you can see here 0 is equal to 0. 0 equal to 0, and also now my J value is also 0. So I have came to a position where my J has been 0. That means total my all characters of the J of my pattern is been matched. So it's going to return what? I. So what it's going to return I? What at point I? At I is I equal to 2. So I can at the last I can say at position I equal to 2, I have found my pattern. So this was the process of a Boyer-Moore algorithm by using a bad character rule. Have you got it? Is there any doubt? Please respond me to the chat box. So this was a Boyer-Moore algorithm by using a bad character rule. So by using this simple bad character rule independently, only by using this bad character, we can implement this PMP, that is pattern matching problem. Okay, what we have done, we'll look once again. We have founded a bad character. If we are getting a bad character, what we were saying that the bad character is going to exist in the pattern or not. If we are finding that, then what we are doing, we are making that mismatch to a match. If suppose that bad character doesn't exist in my pattern, what I have done, I have totally shifted those pattern past the mismatch character. So in that step, in the second example you have seen, as my C has been not matched and it is does not exist in the pattern. So we have totally passed that character and we have tried to match. And now we have seen about the algorithm, how to evaluate the last function, and we have implemented one simple example by using a algorithm also. So have you got this problem? Have you got this bad character rule of the Boyer-Moore? Please respond, anyone. Is it clear? Is it clear, ma? Yes.